There is a moment in any deep dive into medieval engineering when you stop and ask the uncomfortable question: how did people with no power tools, no polymers, no concrete chemistry, and no industrial preservatives create wooden structures that outlived empires? You begin tracing the beams of a 1,000-year-old barn or the foundations of a Viking boathouse and wonder how this material, so vulnerable to moisture, insects and decay in our modern world, managed to survive centuries without crumbling into mulch. If you've ever stood inside a medieval hall and looked up at rafters that have endured storms, roof collapses, fires and endless winters, the answer becomes magnetic. There was knowledge there, deliberate, refined, and frighteningly effective. And the most surprising part is that this knowledge didn't just preserve wood. In many places, it replaced what we now use plastics for: waterproof containers, rot-proof housings, long-term structural supports, even storage vessels for corrosive materials. This wasn't a forgotten craft because it failed. It was forgotten because later governments tried to ban some parts of the process. And today we're bringing it back into the light. The secret begins with using wood at exactly the right moment in its life cycle. Medieval builders understood that harvesting wood was not simply a matter of cutting down a tree. They observed how the sap flowed differently through the seasons and learned that winter-felled timber was dramatically less prone to rot. When a tree was cut during the cold months, the sap content was at its lowest. Less sap meant fewer sugars for microorganisms to feed on, fewer pathways for fungal spread, and, well, fewer attractants for insects. Anyone who wants to apply this today can do it very simply. Fell your wood after the first hard freeze, store it upright for about 2 weeks to drain, then remove the bark while it is still relatively fresh. If you do this properly, you've already extended the lifespan of your timber by decades. The trick continues with shaping, because medieval shaping wasn't just about aesthetics. One of the reasons medieval beams last so long is the way they were hewn. Straight-grained sides, angled cuts and broad faces weren't only structural choices, they were, in fact, moisture management systems. Hewing opened the wood unevenly, exposing harder late-wood layers that resisted water infiltration. At the same time, the shaping eliminated the sap-rich outer layers that rot first. If you've ever wondered why medieval beams look angular instead of round, well, this is why. If you want to replicate it yourself, start by squaring the log by hand or with a chainsaw, then work the faces down until you reach hard, tight grain. You see, this not only makes the timber stronger, but, well, it also helps it shed water instead of absorbing it. The key step, interestingly enough, relies on one of the most misunderstood substances in medieval craftsmanship, controlled charring. This is where the trick becomes, honestly, almost too effective, and where its use was restricted in some regions because of accidental fires. So, medieval carpenters discovered that by lightly charring the surface of wood, just enough to carbonize the outer fibres, they could actually create a natural barrier against rot, fungi, and insects. This technique, which is, still found in parts of Scandinavia and Japan, produced a hydrophobic layer that really slowed down moisture penetration quite dramatically. The charred layer had another benefit as well. It stopped beetle larvae from burrowing through the surface, since they just couldn't digest the carbonized material. So, to apply this nowadays, you can just take a propane torch, heat the surface until it turns uniformly black, but, not flaky. Then you simply brush it gently with a stiff bristle brush and finish it off with a bit of natural oil. When done correctly, you've actually created a wooden surface that surprisingly can outlast some metals. The preservation, well, it becomes nearly permanent when the wood is paired with the right oils and resins. Medieval craftsmen had access to an entire chemical toolkit derived from trees. Pine tar, birch tar, linseed oil, walnut oil, and even resin-based varnishes were used to make waterproofed and rot-proofed surfaces that could last centuries. These weren't random coatings. They were absorbed into the charred layer, filling microscopic gaps and creating what we might today call a biological polymer. In northern Europe, barrels treated with pine tar held liquids for decades without leaking. In the Mediterranean, ship hulls coated in a mix of pitch and oil survived decades of saltwater exposure. When applying this in a modern homestead context, you can mix pine tar and boiled linseed oil in equal parts. Warm it gently and brush it onto your wood after charring. Give it time to cure and you'll have a finish that rivals some synthetic coatings. The final part of the trick lies in how the wood is placed and allowed to breathe. It's really crucial to get this right if you want your timber to last. Medieval carpenters did not bury wood directly in soil unless they treated it first, and even then they created air gaps or used stone footings to interrupt capillary moisture transfer. This, honestly, was a clever way to keep the wood dry and sturdy for years. Wood that sits in stagnant moisture rots, but wood that can release absorbed humidity survives. So, you see, allowing proper airflow is absolutely vital to the longevity of any wooden structure. So, this is why, medieval houses often rested on stone piers, why bridge posts were burned before being driven into riverbeds, and why barns used raised sills even before the Second World War were really widely recognized. You can actually use this today by raising any outdoor wooden structure at least a hand's width above the soil. And, well, you can use gravel beds, stone pavers, or even ceramic tiles as a moisture break. So, understanding this trick really matters, you see, because it gives us a usable long-term alternative to plastics and modern preservatives. If you're restoring a homestead building, slow decay structures, storing food, making livestock shelters, or crafting tools that need to endure harsh climates, this medieval approach gives you a method that relies on biology instead of chemicals. A charred, oil-soaked, winter-felled beam can survive outdoors longer than pressure-treated lumber. A tar-coated wooden box can store dry goods as reliably as plastic. Even fence posts treated with controlled charring can last 3 to 4 times longer than untreated ones. These aren't theoretical claims. They are practical techniques you can implement with basic tools and a weekend of work. If you found value in this deep dive into medieval preservation techniques, make sure you subscribe to the channel, share this video with fellow history enthusiasts, and help keep this kind of knowledge alive.